research focuses on mountain glaciers and mountain glacier mass change. So while these glaciers often exist in really remote, harsh, inaccessible environments, we actually have a ton of data from satellite-based data products that enable us to observe pretty much all of them globally. That said, these products are limited in their spatial and temporal resolutions, and they measure directly the surface elevation change of glaciers. So my research specifically is focused on disaggregating these surface elevation change products into two primary components, the first being contributions from the climate, also known as the climatic mass balance. This is basically the sum of accumulation and melt at any point on the glacier. And the second being contributions from glacier dynamics, also known as the flux divergence. And this is basically surface changes resulting from the ice flow or the transport of ice downhill due to gravity. We've deployed a series of monitored banded ablation stakes. So we have these time-lapse cameras that image our ablation stakes every day and give us really high accuracy daily measurements of the climatic mass balance. And we've also deployed a series of low-cost GPS systems that we put on top of our ablation stakes, which also give us direct observations of the flux divergence in addition to the climatic mass balance. And not only will these enable us to really understand all the processes, get a really holistic view of what's going on volcanic glaciers specifically, but they also give us really invaluable ground truth calibration and validation data for models and our remotely sense-derived products, which we can then use to extrapolate beyond volcanic glacier into the broader Alaska region. I really do kind of cherish the multifaceted elements of my research. On one hand, I'm reading papers and coding just like any other PhD student, but on the other hand, I do get to travel to Alaska, go on these glaciers, get a really different experience out in the elements. It's a different type of adversity you're facing than just thinking of a research problem or writing a paper, how to design a figure.
And so what Albin's work is doing is really advancing the systems that we're using to measure the changes on the glaciers at a very high spatial and temporal resolution. And what that enables us to do is it provides unprecedented level of detail that we can use to calibrate and validate models, but we can also think about the remote sensing data that we have and through how we can scale these in situ measurements up to all glaciers globally through the use of remote sensing. And in doing that, we can really extend the reach from our work on a single glacier to an entire region and potentially all glaciers globally.